Hi everyone, I welcome you all to my maths class today, and today we're using probabilities. Probability is a branch of mathematics that deals with the occurrence of a random event. Okay, so today we'll be solving different questions, JAMB related questions, WAEC related questions on probabilities. Please feel free to drop in suggestions, observation, questions in the comment section. So let us dive in and solve more questions on probability. You are welcome. The question says, in a single throw of two fair coins, find the probability that A, two heads appear, B, two tails appear, C, one head, one tail appear. Solution. So we have two fair coins, so when we throw it, so let's just say S is our sample space, which means it will house in the total number of possible outcomes we can have as a result of throwing the two coins. So when we throw the two coins, we can have two heads at the same time, we can have two tails at the same time, we can have a head and a tail, and we can have a tail and a head. Okay, these are the four possible outcomes we can have as a result of throwing two fair coins. So the requirement is we should find the probability that two heads appear. So A, so from here, two heads appear is this, two heads appear from everything here, that is 1 over the total number of possible outcomes is 4. So we have 1 over 4. The second one is two tails appear. From these possible outcomes, two tails appear, which is this, two tails appear is still 1 over 4. And the third requirement is this. We should find the probability that one head and one tail appear. So when we look at the sample space here, one head and one tail, that is 2. So that is 2 over the total number of possible outcomes is 2 over 4 or 1 over 2. Using a coin and rolling a die, coin and a die are two separate events. They are independent events. So what is the probability of obtaining a tail on the coin and an even number on the die? That is the requirement. Solution. For a coin, the possible outcome from a coin can either be head or tail, the head or tail, and rolling a die. For a die, probability of rolling a die, you can have 6 outcomes. Okay, today we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 for a die. Now, the question says, what is the probability of obtaining a tail on the coin and an even number? So we have to figure out the probability of obtaining a tail from a coin is just 1 over 2. Either we have the head or the tail. And probability of obtaining an even number, okay, an even number from a die is, the even numbers are 2, 4, 6, that is 3. So that is 3 over, the total is 1, 2, 3, 4, 5, 6 over 6, which is 1 over 2. This for a die, and this for a coin. The question says, so what is the probability of obtaining both from the die and the coin? 1 over 2 times this, you multiply these two results, so we have 1 over 4. Find the probability that a number selected at random from 21 to 34 is a multiple of 3. Solution. So let us write out. From numbers between 21 and 34 are 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So which among all these numbers are multiples of 3? So 21, 3 times 10 is 21, 24, 3 times 8 is 24, 3 times 9 is 27, 3 times 10 is 30, 3 times 11 is 33. So we have how many? We have 1, 2, 3, 4, 5. So the probability of picking a number as from 21 to 34, which are multiples of 3, is 1, 2, 3, 4, 5. That is 5 over The total number of outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is 5 over 14. If x and y can take the values from the set 1, 2, 3, 4, this is the elements of the set, find the probability that the product of x and y is not greater than 6. This is the requirement. You should find the probability that the product of x and y is not greater than 6. The first thing is for us to determine the value of x and y, because they take their values from this sets 1, 2, 3, and 4. And how do we go about it? We have to determine the total possible outcome of x and y. And you can do this by having it in this way: 1, 2, 3, 4. 1, 2, 3, 4. You can have a simple table like this. So we are doing this to figure out the total possible outcome of xy. So how do we go about this? You cannot say 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. So we have how many possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. These are the total number of possible outcomes we can have. But the question says we should look at numbers that are equals to 6 or less than 6. So what are the numbers here that are less than 6 or equals to 6? We have 1, 2, 3, 4, 5, 6, 7. 6 inclusive. 8, 9, we have 10. So that means probability of getting numbers less than 6 or equals to 6 is 10 over 16 or 5 over 8. The question says a box contains 2 red balls and 4 blue balls. A ball is drawn at random from the box and then replaced before a second ball is drawn. Find the probability of drawing 2 red balls. Solution. So we are having 2 red balls in the box. So probability of having a red ball will be equals to 2 over the total number of balls is 6. That is, we have 2 red balls, and 4 blue balls, so making 6. All right, so probability of picking a red ball is 2 over 6, which is 1 over 3. Now the question says, from here, a ball is drawn at random from the box and then replaced before the second ball is drawn. So we already know the first one to be 1 over 3. We are now asked to find the probability of drawing 2 red balls. Probability of drawing the first red ball is 1 over 3. So since the ball is replaced before the second draw, so that means that the probability of drawing a red ball on the second red ball is still 1 over 3. So we multiply by 1 over 3. So we have 1 over 9.